Equations that involve terms of the form b to the x, where b is greater than 0 and b is not 1, are referred to as exponential equations. When these equations have a like basis, we can use the correct laws of exponents to do the following. We can put into the form of b to the u equals b to the v, where we can just disregard b's and focus on their exponents. So, again, just to repeat it, it just says that we can take the bases on both sides of the equation to be the same, and that we can get rid of them because since they're equal, we need to focus on what's not equal, and that being the exponents. What we have to do is we have to get them to be the same if they're not already the same. And we have to use the laws of exponents to be able to do that. So again, pretty easy to do. Just have to be good with exponents. So first we have 7 to the x equals 7 to the third. So again, 7 to the x equals 7 to the third. Both bases are the same. Both are 7s raised to a power. So we can just disregard the 7s and just focus on the exponents as x equals 3. And solve. Well, it's already solved for me. X equals. So here's my answer. X equals 3. That's all there is to it. Next we have 2 to the x equals 16. Unfortunately, the bases are not the same. This is a 2 and this is 16. However, I can take 16 because I remember my rules of exponents, and I can say that 16 is just 2 to the fourth. Now I have the exact same bases, so I don't have to worry about the bases anymore. I can get rid of these 2's as a base and focus on the exponents, which is just going to be x equals 4. And there's my solution to this exponential equation. So there's some easy ones. Let's do one that's a little bit more challenging. 1 to the fifth raised to the x equals 25. Well, this is to the fifth power, and this is a 1/5 as a base, and this is a 25. Well, I can take 25, and I can say it's just 5 squared. Nothing too difficult about that, but I still needed to make it look like it's a fifth. So I can use my rules of exponents and move this 5 into the denominator, and it will become 1/5. So I can say that 1/5 to the x is equal to 1/5, or 1/5 to the -2. Now it's pretty close to it, but now I can take this -2 and move it out because 1 to any power is always going to be itself. So I can say that 1/5 to the x is equal to 1/5 to the -2. And now that I have the exact same bases, get rid of them and focus on the exponents. So x equals -2. And here is my solution to this exponential equation. Now this one here, a little bit different, but again, nothing too bad. So 8 raised to the -x plus 14 equals 16 raised to the x. So I'm going to work on this and get the bases to be the same. So 8 and 16, well, I can say that 8 is just 2 cubed to the -x plus 14. And I can say that 16, like with the other question, is just 2 to the fourth, all raised to the x. And again, rules of exponents says that an exponent to an exponent can be multiplied. So I could say this is just 2 to the 3 times -x plus 14. And this is just 2 to the 4x. Now that my bases are equal, I no longer need them. So I'm going to focus only on the exponents. So 3 to the -x plus 14 equals 4x. And now I'll solve. Distribute the 3 inside, so it'll be -3x plus 42 equals 4x. Add 3x over, We're going to get 42 equals 7x, and then divide by 7, 6 equals x. And here's my solution to this exponential equation. Last, I have e to the 3x equals e to the 2 minus x. Well, the bases are e on both of them, so e to the 3x equals e to the 2 minus x. So since the bases are the same again, even if they're just e's, we can get rid of them and focus on the exponents. So 3x equals 2 minus x. So I'm going to add x over, get 4x equals 2, then divide by 4. X is going to equal 2 over 4, which we can say is just 1/2. So the answer to this exponential equation with a similar base is 1/2.